Hello everyone, welcome back. Today we'll be looking at session 9. We'll be learning how to work with advanced queries and joins. Let's get started. The session objectives for today: at the end of this particular session, participants will be in a position to explain grouping and aggregating data. You learn how to work with subqueries. You learn how to describe table expression, explain joins, describe various types of joins, explain the use of various set operators to combine data, and also learn how to pivot and group set operations. Let's get started by looking at the introduction. Now, SQL Server includes several powerful query features which help you to retrieve data efficiently and quickly, and data can be grouped and or aggregated together in order to present summarized information. Using the concept of subqueries, a result set of a select statement can be used as a criteria for another select statement or query. Joins help you to combine column data from two or more tables based on a logical relationship between the two tables. And the set operators such as union and intersect help you to combine row data from two or more tables. The pivot and unpivot operators are used to transform the orientation of data from column-oriented to row-oriented and vice versa. The grouping set subclause of the group by clause helps to specify multiple groupings in a single query. Okay, grouping data. Now, this group by clause partitions the result set into one or more subsets, and each subset has values and expressions in common. The group by keyword is followed by a list of columns known as the grouped columns, and every grouped column restricts the number of rows in the result set. For every grouped column, there is only one row. The group by clause can have more than one grouped column, and the syntax for the group by clause is given below. Sorry, there was a typo here. Let's just move on to the next slide. Now, we have this example here. We are told to consider the work routing table in the AdventureWorks database. The total resource hours per work order needs to be calculated. To do this, the records need to be grouped by work order number, that is the work order ID. The following code snippet retrieves and displays the total resource work hours per order along with the work order number. Now, what I want us to do right now is this exercise very quickly. So we load the solution we have been working on from recent solutions. You remember how to go about that. Click File, then scroll down to Recent Solution, select that solution. Then please create this script called SES9 Advanced Queries and Join. So let's do this very quickly. Watch the video here, do this, then come back. You'll find me already having done it. We want to write the purpose of what it is that we'll be covering today. This session covers advanced queries and joins. Okay. Then we switch over to AdventureWorks. You can use the switch statement. Okay, execute this statement so that we switch to the AdventureWorks 2016 database. Execute. Then now you can save your query. Now let's go back to your slides. We want to copy this query. So highlight. Then after highlighting, copy, switch back to the query window and paste. Now I've pasted and written the comment explaining what it is that we want to do. Now the only thing that remains is to highlight and execute this. Highlight, then click on execute, and we get the results displayed there. We move on. In this query, a built-in function named sum is used to calculate the total. Sum is an aggregate function, and aggregate, basically we are totaling something, and aggregate functions will be covered in detail in a later section. Now, if you are quite curious to find out what these are, you can open Google, Yahoo, or any other search engine and find out about SQL Server aggregate functions. We move right on. Executing this query will return all the work order numbers along with the total number of resource hours per work order. A part of the output is shown in this image here, or what it is that we got in our query window. We move right on. Group by with where. Now the where clause is also used with the group by clause to restrict rows for grouping. The rows that satisfy the search conditions are considered for grouping, and the rows that do not meet the condition in the where clause are eliminated before any grouping is done. The following code snippet shows a query that limits the rows displayed by considering only those records with a work order ID less than 50. So as usual, highlight, then copy and switch over to the query window. Okay, all done. I have reformatted my query to make it easier to read, and I've written what it is that we want to do. Comment is right in line 9 and line 10. Then let's highlight this and execute it. Okay, we get the output there. Let's move right on. So you can see the results are displayed here. So as the number of records returned is more than 25, part of the output is given here. We move on. Group by with null. Now, if the grouping column contains a null value, that row becomes a separate group in the result set. If the grouping column contains more than one null value, the null values are put into a single row. Consider the production.product table. There are some rows in it that have null values in the class column. Using a group by on a query for this table will take into consideration the null values too. The following code snippet retrieves and displays the average of the list price for each class. We have select class, then average of list price as using an alias. Then you select the table and the schema, and we want to use the class for grouping, and that is the expected output. So very quickly, let's highlight and copy, switch over to the query window. Okay, all done. So the purpose of the query is listed here, and we highlight the query and execute it, and we get the same results as in your slides. We move right on. Group by with all. Now the all keyword can be used with the group by clause, and it is significant only when the select has a where clause. We are saying when the all is used, it actually includes all the groups that the group by clause produces. It even includes those groups which don't meet the search conditions. And the syntax of the group by with all is given below. So select, then you specify the column from the table, then where you specify the condition, then finally you group by all, then you tell us the column by which you'd like to use. Let's look at an example very quickly. Now consider the sales territory table in the sales schema. This table has a column named group, indicating the geographic area to which the sales territory belongs to. The following code snippet calculates and displays the total sales for each group. Select group, then sum, sales year to date as total sales from sales.sales territory, where group like, so we want to group with those starting with N or those starting with letter E, then we group by group. Now, something I would like to mention, if you look at this word group, it's actually in square brackets. If you remember, we talked about this earlier, and we actually said that for keywords in SQL Server, to avoid confusion, you can see we have this word group here. So to avoid confusion of the keywords with column names, you actually put them in square brackets. So please highlight this, copy and switch over to the query window. Okay, we have the path of the query, line 22 and 23. We have the query itself. We highlight, then execute it. We get the results given here. And you can see that we have some regions which don't meet the criteria. Pacific does not start with N or E, but due to the group by all, that is why it's giving us the result for Pacific. We move right on. Group by with having. Now the having clause is used only with the select statement to specify a search condition for a group, and the having clause acts as a where clause in place of the where clause. Okay, we are saying that the having clause acts as a where clause in places where the where clause cannot be used against aggregate functions such as sum. Once you have created groups with a group by clause, you may wish to filter the results further. The having clause acts as filters on groups, similar to how the where clause acts as a filter on rows returned by the from clause. Let me give you a practical example. We want to find out students who are enrolled in January this year. You specify where the students were enrolled in January. Then you want to group them by courses. So group by course. Then finally, you want to select those students who have fee balances. You can now use the having to select that. That is how the having clause works. We have said the having clause works like a where, but only when you have grouped. Please remember that. A business example could be a company having several branches. We want to group by, let's say it's sales. We group the sales by branches, but we only want to display those sales which exceed, like let's say 10 million. That is how you can use a where and having at the same time. Let's look at an example. So syntax first. So the syntax is given here. Select column name from table name, group by, then select having, you specify the criteria. And the following code snippet displays a row with the group Pacific as its. So highlight it, then copy and switch over to your query window and paste there. Let's do that very quickly. And this is the expected results. The purpose of the query is listed here. Kindly highlight and execute this. And we can see we are not getting any results here. Okay, so there is no group having sales less than 6 million. What we could do maybe is to get the average. So let me save this first. Now copy this and paste below and change it to look like mine. So this one now is going to display the groups or region having average sales of less than 6 million shillings. Now notice we have this other function. You can go and find out what this does. And if I hover, you can see it's giving you built-in function AVG expression. It returns an integer. So if I highlight this now, I think it should give us some results. And you can see what it is that we have here. So we have Europe, which has about 4.5 million, and we have North America, which has 5.53 million, and we can move right on. Now, looking at this critically and looking at the answer given in your slides, I've noted that there's some discrepancy. So apart from this, now this is the expected output. We want to get one row. The name should be Pacific, and this is not the total sales, it should be the average sales. So the first thing we're going to do is to modify our query a little bit. Let's switch back over to SMS Management Studio. Let's look at this query. Now modify your query to look like mine. I've changed the comment and also changed here. Now, first of all, I want to display all the groups. I'll comment out the where clause. So I'll come here and click on comment. Okay, then execute it. You can see what it gives us. This is the answer we are looking for. So what we can do is maybe like specify the amount should be greater than, let's say 5.6, but less than 6.6 million. So let's change that very quickly. Okay, now look at my line 43. I have added average sales should be greater than 5.6 million and average sales should be less than 6 million so that we get the results in your slides. Let's highlight this now, execute it, and we get the results as given in the slides. Okay, I know there are a few errors in the slides, but don't worry so much about it. We'll see how we can make corrections. After all, they're made by human beings like you and me. Sorry for the oversight. Let's move right on. Cube. Now, the cube is an aggregate operator that produces a superaggregate row in addition to the usual rows provided by the group by. It also produces the summary of the rows that the group by clause generates. The summary row is displayed for every possible combination of groups in the result set, and the summary row displays null in the result set, but at the same time returns all the values for those. Syntax for the cube function is given below. Select to specify the column, then the table, then group by. You select the column which you want to group by, then finally with cube. We have an example here, so kindly copy this and switch over to your query window. Now we want to fetch all the total records of countries other than Australia or Canada. That is why we're using the not operator before the names of the countries. We highlight this, click on execute, and this is the expected results. The next one is the rollup function. Let's move on. Now, in addition to the usual rows that are generated by the group by clause, it also introduces summary rows into the result set, and it is similar to the cube operator but generates a result set that shows the groups arranged in a hierarchical order. So it arranges the groups from the lowest to the highest, and the group hierarchy in the result set is dependent on the order in which the columns that are grouped are specified. So syntax is basically the same. The only key difference is with rollup. So the difference between rollup and cube is that this one basically displays the results sorted or arranged in hierarchical order. That is from the lowest to the highest. Let's look at an example. So we have this, so highlight this, copy and paste. Alternatively, what you have here, you can just highlight this, copy, come down here and paste. So I'll tap on enter, then paste. Then instead of using cube, I'll now change this to roll up. That way. Now notice the results here. We don't have any specific ordering in the country. Okay. But let's execute this and see what happens once we execute this with rollup. So execute. So notice now that the name of the country is starting with C, F, G, all the way to U. So that is the key distinction between when you execute this using cube and once you execute it using rollup. We move right on. Aggregate functions. Now, aggregate functions help to perform analysis across rows, such as counting the rows, meeting a specific criteria, summarizing total rows for all the orders. And aggregate functions return a single value that and can be used in select statements with a single expression, such as select, having, and order by. Aggregate functions ignore nulls except when you're using the count all or count star. And the aggregate function in a select list do not generate column alias. You may wish to use them as close to provide one. You notice that that is what we have been doing with the queries we've written so far. Now, aggregate functions in a select clause operate on all rows passed to the select phase, and if there is no group by clause, all rows will be summarized. SQL Server provides many built-in aggregate functions, and the following table lists the commonly used functions. Now, remember I told you earlier on to open your favorite search engine and you type in the phrase SQL Server aggregate functions, and you'll be taken to the Microsoft documentation site, and from there you can have a look at some of the functions, and they even go ahead to give you examples for this. Now, what it is that we have here in the slides is not an exhaustive list. Basically, we are covering most of the commonly used aggregate functions. We have already seen the average function, which basically calculates the arithmetic mean, and this is the arithmetic mean of all the non-null numeric values in a column. We have the count and count big, the count or count expression. So when used with an asterisk, this function counts all the rows including those with null. The function returns the count of non-null rows for the column when a column is specified as expression, whatever it is that you want to count. The return of the count function is an integer, while the other one, the count big, returns a big int. Max basically gives us the largest number, latest date or time, or the last occurring string, while minimum basically does the opposite. That is, it gives us the least number or the smallest number, the earliest date or time, or first occurring string. The sum function, basically we are totaling, and it calculates the sum of all non-null numeric values in columns, in a column. Okay, let's look at an example here. So kindly highlight this, copy, and switch over to the query window. I have written the purpose of this query from line 59 to 61. Then we can execute it. We can highlight and execute. Click on execute, and it gives us this. So the average unit price is given there. The minimum order quantity is 1, and the maximum discount you can get is 40%. We move right on. Now, when using aggregates in a select clause, all columns referenced in the select list must be used as inputs for aggregate functions, or they must be referenced in a group by clause as we looked at previously. Failing this, there will be an error. Okay, the following code snippet will return an error. So please highlight this and let's see what happens. Okay, I've written the purpose of the query and you notice it's not going to work. Reason being that this column here, sales order ID, is not going to, it's not used in a group by or in an aggregate function. And it doesn't make sense for you to like try to group the IDs, because IDs basically uniquely identify the sales orders, and of course you don't want to add the IDs together. It doesn't make sense. It's also like you trying to add phone numbers. Now let's execute it, and remember it's not going to work, so click on that, and you notice the error that we're getting here. So it tells that column sales, then okay, this is the sales schema, sales table, sales order ID column. So this is invalid in the select list because it is not contained in either an aggregate function or in a group by clause. So if we wanted this to work, basically what we will do is just to remove this. So I can highlight this, tap on the delete key. Then now once you execute this, you can see it basically works. Okay, so let me just bring it back. I'll undo. Then we can save and move right on. As the query is not using a group by clause, all rows will be tested as a single group All columns therefore must be used as inputs to aggregate functions. Now, to correct or prevent this, we've seen what happens. Besides using numeric data, aggregate expressions can also include date and time and character data for summarizing. And the following code snippet returns the earliest and latest order date using the min and max functions. Kindly highlight this, copy, and switch over to the query window. Now, the purpose of this query is written in line 71. And we go right ahead and execute it to get the earliest and latest orders, and we get this as the results. Now, this is a bit different from what you have in the slides. You can see in your slides it's giving the earliest date is 2005, while this one is 2008. Remember, we pointed that out. Your slides is using the AdventureWorks 2012 database, while we're using the AdventureWorks 2016, and we pointed out that there are some changes which were made by Microsoft on this sample database. We move on. Spatial aggregates. Now, SQL Server provides several methods that help to aggregate to individual items of geometry or geography data, and the following table lists the methods. We have the ST union. So this basically returns an object that represents the union of geometry or geography instance with another geometry or geography instance. ST intersection, so this returns an object that represents the points where a geometry or geography instance intersects another geometry or geography instance. We have the ST convex hull, which returns an object representing the convex hull of a geometry or geography instance. And a set of points we are saying that a set of points is called a convex if for any 2 points the entire segment is contained in the set. The convex hull of a set of points is the smallest convex set containing the set. For any given set of points, there is only one convex hull. Now, what we want to do is to explain what these spatial aggregates are, and I would like to give you a URL that you can reference. Let me just display it here. Now we have these 2 links. Please feel free to look them up. I currently don't have an internet connection. This is the sites. I've already bookmarked them. So make sure you look this up. I hope by the time you're watching this that these links are still functional. Let me comment both of them out. They're not part of the scripts. We move on. Kindly make sure you read on this so that you can understand what it is that we are doing. Now, we have this figure which depicts an example of ST union. So we have these 2 shapes. We have a rectangle and we have a square. And once you use the ST union function, basically this is what it gives you. So we are combining the square and the rectangle. So combining the 2 polygons using the ST union method results in a merged polygon. The following figure depicts an example of ST intersection. We have this pentagon and this hexagon, and this is the part which we are uniting. Sorry, this is the part where they intersect, and this is the outcome. Using the ST intersection with 2 polygons can lead to another polygon. Then we have the last one. The following figure depicts an example of ST convex hull. And if you look at this, it's like that thing you did in kindergarten of joining the dots. But basically, we are joining the outer dots. Notice that these 2 dots are basically left out. Let's look at some examples. Now, the following code snippet demonstrates the use of ST union method. So kindly highlight this, copy, and switch over to the query window. This is the expected result. Okay, I've pasted, and as you can see here, I've written the purpose of this particular query. Now highlight this, then execute. Now you notice now we have 3 tabs in the results window. We have the results tab, we have the spatial results, and we also have the messages. So we are interested in this. And to get exactly what it is you have on the slides, you can deselect that. And you can see we have these two dots. Let me zoom out completely. Now you can see the dots get closer to each other, and the more you zoom in, the dots basically are no longer visible. We move right on. The following code snippet displays another example, so kindly highlight this, copy, switch over to the query window. Now for this one, it's actually spanning two slides, so it goes all the way up to here. So make sure you highlight both and paste. Make sure you compare what it is that you have pasted with what I'm going to paste. Okay, we have this. I'll highlight, then execute. I'll click on the spatial results, and you can see you can zoom in or out, and you can either hide or show the grid. It's basically depends on your tastes and preference. Okay, we move on. We have new spatial aggregates. Now, these ones were introduced in SQL Server 2012, and they are namely union aggregate, envelope aggregate, collection aggregate, and finally we have the convex hull aggregate. These aggregates are implemented as static methods which work for either the geography or geometry data type. And although aggregates are applicable to all types of spatial data, they can be best described with polygons. Union aggregates. Now, it performs the union operation on a set of geometry objects, and it combines multiple spatial objects into a single spatial object, removing interior boundaries where applicable. The syntax of the union aggregate is given below. Union aggregate, then either you pass in a geometry operand or a geography operand. Now, if you've read those two articles I've listed, you should actually understand what it is that is happening here. So where the geometry operand is a geometry type table column comprising the set of geometry objects on which union operation will be performed, and the geography operand is a geography type table column comprising the set of geography objects on which on which a union operation will be performed. We look at an example. Now the following code snippet demonstrates a simple example using the union aggregate. It uses the person.address table in the AdventureWorks database. Select geography, union aggregate, spatial location as average location from person.address, where city is London. So please highlight this, copy, and switch over to the query window. The purpose of the query is listed in line 94, and we can highlight the query, click on execute. We get this, and the spatial results are given here. You can disable the grid lines and we can get this. Okay, we move right on. Next is the envelope aggregate, and this basically returns a bounding area for a given set of geometry or geography objects. It exhibits different behaviors for geography and geometry types. For the geometry type, the result is a traditional rectangular polygon which closely bounds the selected input objects. For the geography type, the result is a circular object which loosely bounds the selected input objects. Furthermore, the circular object is defined using the new curve polygon feature. And the syntax of this envelope aggregate method is given below. Envelope aggregate, then you either pass in a geometry operand or a geography operand, where geometry operand is the geometry table column comprising the set of geometry objects, and The geography operand is a geography type table column comprising the set of geography object. And we have this example. Kindly highlight copy, then let's meet in the query window. Okay, the purpose of the query is listed in line 100. We highlight and execute this. We look at the spatial results tab and we can see what it is that we are getting. Okay, now for them they've hidden the grid, so you can hide the grid if you don't want to see it as well. Okay, collection aggregate. Now this one basically returns a geometry collection or geography collection instance with one geometry or geography part for each spatial objects in the selection set. The syntax of the collection aggregate is as follows. So collection aggregate geometry operand or geography operand, where the geometry operand is a geometry type table column comprising the set of geometry objects. Geography operand is a geography type table column comprising the set of geography objects. The following code snippet returns a geometry collection instance that contains a curve, polygon, and a polygon. So we'll highlight this. It goes all the way to the next slide. So highlight this, then copy, and let's meet in the query window. Now I've written the purpose of this query and I've reformatted my query just to make it easier to read. You can just leave it exactly the way it is in the slides, or you can modify it like mine so that it's easier for you to read. Let me hide the results window so that you can see the entire query. So this is the entire query starting from line 106 all the way to 119. Now I'll highlight, then execute, and you get the results given here. You can hide or display the grid depending on your taste and preferences. So here they've hidden the grid. Let's move on. Convex hull aggregate. Now it returns a convex hull polygon which encloses one or more spatial objects for a given set of geometry or geography objects. And the following is the syntax of the convex hull aggregate. Convex hull aggregate, geometry operand or geography operand, where the geometry operand is a geometry type column comprising the set of geometry object, and geography operand is the geography type table column comprising the set of geography objects. We have an example, so please highlight this, copy. Let's meet in the query window. Now the purpose of the query is here, line 121. Let me save my work, and we highlight this and we execute it, and we look at the spatial results tab, and this is what we get. Okay, then we finally start looking at subqueries. Now you can use a select statement or a query to return records which will be used as the criteria for another select statement or query, and the outer query is called the parent query while the inner one is called the subquery. The purpose of the subquery is to return results to the outer query. In other words, the query which is inside should return the column or columns which you want to use as the criteria for the parent query. Now, the simplest form of a subquery is the one that returns just a single column, and the parent query can use the results of this subquery using an equals sign. Now, the syntax for the most basic form of a subquery using just one column with an equal sign is given below. We have the select statement. You choose the column, then you tell us the table from which you want to get the results. You give us the condition using the where clause, then equals, then inside the parentheses or brackets, you write the select statement. Select then column name, from table where column name equals the condition that you want to, the filter condition you want to use. Now, in a subquery, the innermost select statement is executed first, and its result is passed as the criteria to the outer select statement. Consider a scenario where it is required to determine the due date and ship date of the most recent orders. The following code snippet shows the code to achieve this. Select due date, ship date from sales.sales order header, where sales.sales order header dot order date is equals to, then we do the inner query. Remember what the max function basically does. So kindly highlight this, copy, then let's meet in the query window. Okay, all done. Now I've written comments for both the parent query and the child query or the subquery, and I've reformatted my work. This is entirely optional. It's just that I want to make my code easier to read. We highlight, then we execute this, and you can see the results which we are getting. Now, okay, if we compare the results we have, I hope you remember what it is that we talked about, the AdventureWorks 2012 and 2016 issue. That is why the results are a bit different. Now, based on the results returned by the inner query, a subquery can be classified as either a scalar subquery or a multi-valued subquery. Let's start by looking at the scalar subquery. Now, this one returns a single value, and here the outer query needs to be written to process a single result. For multi-valued subquery, it returns a result similar to a single column table. Here, the outer query needs to be written to handle multiple possible results. Now we look at working with multi-valued subqueries. Now, if an equals operator is used with the subquery must return a single value, as we've seen previously. And if more than one value is returned, there will be an error and the query will not execute or will not be processed. The keywords any, all, in, and exists can be used with the where clause of a select statement when the query returns more than one query, but one or more rows. Now, the simplest form of a subquery is one that returns just one column, and the parent query can use this result of the subquery by using an equal sign. These keywords, also called predicates, are used with multi-valued queries. Example, consider all the first names and last names of employees whose job title is Research and Development Manager. So we need to display the first names and last names of those people whose job title is R&D Manager. Now here, the inner query may return more than one row, as there may be more than one employee with that JD or job title. And to ensure that the outer query can use the results of the inner query, the in keyword will have to be used. Okay. Now the following code snippet demonstrates this. So select first name, last name from person.person, where person.person.business entity ID in. Now we are using the inner query. Notice we have now the opening parenthesis or bracket. So select business entity ID from HR or human resource schema, employee table, where job title equals research and development manager. So kindly highlight this and copy. Then let's meet in the query window. Okay, the purpose of this, the outer query or the entire query, is written in line 137 and 138. The purpose of the inner query is given in line 143. Let me collapse the results window, and we can execute this to get the names of those people who are working as research and development managers. Okay, so we have these two, Dylan and Michael. Now here, the inner query retrieves the business entity ID from the hr.employee table for those records having job title R&D manager, and these results are then passed to the outer query, which matches the business entity ID with that in the person.person table. Finally, from the records that are matching, the first and last names are extracted and displayed. The following table displays the results. Okay. Now, there are some things you need to remember when working with subqueries. The in-text, text, and image data types cannot be used in the select list of a subquery. The select list of a subquery introduced with a comparison operator can have only one expression or column name. Subqueries that are introduced by a comparison operator, not followed by the keyword any or all, cannot be used in the group by or having clauses. You cannot use the distinct keyword with subqueries that include the group by, and you can specify the order by only when you have specified the top keyword. Now, besides scalar and multi-valued subqueries, you can also choose between self-contained subqueries and correlated subqueries, and these are defined as follows. So for self-contained queries, these queries are written as standalone queries without any dependencies on the outer query. A self-contained subquery is processed once when the outer query runs and passes its results to the outer query, while a correlated subquery, now the queries reference one or more columns from the outer query and therefore they depend on the outer query. Correlated subqueries cannot run separately from the outer query. Now we'll see an example of a correlated query in subsequent slides. Let's look at the exists keyword. Okay, we want to look at the exists keyword, and this is used with the subquery to check the existence of rows returned by the subquery. And the subquery does not actually return any data. It returns a value of true or false, indicating whether the search item actually exists or doesn't exist. And the syntax is given below. So select column name from table where not exists. So that is, the not is in square bracket, meaning it's optional. Where something does not exist or where something exists. Then the subquery statement, and this subquery statement specifies the subquery. Now, let's look at an example here. The following code snippet shows the use of the exist keyword to yield the same output. We want to find out people who are working as R&D managers. So that is going to be done using the inner query. And if there exists somebody who has that job title, then we return their first name and last name. We explain what is happening. Now here the inner query retrieves all those records that match job title as research and development manager, and whose business entity ID matches with that in the person table. If there are no records matching both these conditions, the inner subquery will not return any rows. Thus, in that case, the exist will return false, and the outer query will also not return any rows. However, the code will return 2 rows because the given conditions are satisfied. Similarly, one can use the not exist keyword. The where clause in which it is used is satisfied when there are no rows returned by the subquery. So please highlight this, copy, and let's meet in the query window. Okay, the comment is given here, line 150 and 151. I've already saved the work. Then we highlight the query, execute it, and you can see we still get the same results. Let's move on. Nested subqueries. Now, a subquery that is defined inside another subquery is called a nested subquery. And I should caution you in using this, especially due to performance in your database. Consider that you wanted to retrieve and display the names of persons from Canada. There is no direct way to retrieve this information since the sales.sales territory table is not related to the person.person table. Here, or hence, a nested subquery is used as shown in the following code snippet. So kindly highlight this, copy, I've copied and pasted and made a few changes. Now I've written the purpose of the entire query. So we want to use the nested subqueries to display the names of individuals from Canada. Now I've made a little modification using the concat function. This is basically used to join strings, and these are going to be returned in a column called names. You can do this or just have it exactly the way it is in your slides. Then the outer subquery is used to extract the person's business entity ID, while the innermost subquery is used to extract the territory ID whose name is Canada. So we highlight everything, then we can execute this, and basically we get the names given here. Now, if you want to execute it exactly as it is in your slides, this is what you do. So I'll remove this function, delete that, and this space, remove one of these commas, then I can remove that. Then now you can highlight, then click on execute, and basically it gives you this. So basically it's just a matter of preference, however you want to go about it. I'm going to take it back to what it was. Then save. Let's move right along. Okay, as promised earlier on, we want to look at the correlated queries. So a correlated subquery is one that takes parameters from its parent query, as you can see here. Now consider that you want to retrieve all the business entity IDs of persons whose contact information was last modified not earlier than 2012. So the following code snippet displays the use of a correlated subquery. So we have this subquery here inside, and we have the parent query. So what we do, please highlight this, then let's meet in the query window. Now the purpose of this query is written up here, and we are going to highlight and execute this, and these are the results which we get. We go back to the slides. Now in the code, the inner query retrieves the contact type IDs for all those persons whose contact information was modified on or before 2012, and these results are then passed to the outer query, which matches these contact type IDs with those in the person.business entity contact table and displays the business entity IDs of those records. And the following figure shows the output, shows part of the output. Okay, now we are going to leave this session here. So in the next part, we are going to look at joins. So I'll see you in part 2 of session 9.